13.1. In this lecture video, let me show you how to let me how you do these type of problem called the factoring by grouping. Okay, now I'm gonna go to another page. I'm gonna write this down. So basically, what I'm going to show you is 6 different types of factoring problems. The very first one is what I showed you in the previous video, which is factoring out the greatest common factor of a polynomial. Alright, the second type is what I'm going to show you today, which is actually called factoring by grouping type of problem. Okay, alright, we will learn in module 13.2 and 13.3, we will learn how to factoring what we so-called the trinomial. Okay, and then the following in module 13.4, we will learn how to factoring difference of squares, the same difference of square that we talked about back in module 12, and I hope you still memorize the formula. Another type is actually called factoring the perfect square binomial or trinomial. I call it perfect square binomial. And the sixth type is actually called the sum and difference of cubes. Okay, so these are the 6 type I'm going to show you from module 13.1 to 13.4. Okay, so let's take a look at what we so-called the factoring by grouping. Factoring by grouping is a very particular type of factoring problem. It actually requires factoring the polynomial twice. It has 2 key characteristics. Number 1, we're gonna have 4 unlike terms. Okay, got to be unlike terms so they will not be able to, so therefore there is no like term to combine. Number 2, there are going to be no greatest common factor between the 4 terms. So I'm going to have 4 unlike terms and no greatest common factor between the 4 terms. In that case, we got ourselves a factoring by grouping problem. So the first step is just like the wording says, group the first 2 and the last 2 terms. Then step number 2, factoring out the greatest common factor between the first 2 and the last 2 terms. Once we've done that, now we will actually end up with 2 terms, okay? And what's inside the parentheses of each term should match up. So once they match up, then what's inside the parentheses becomes another set of greatest common factors. So we can factor out the greatest common factor again. All right, so let me show you what it look like. Factoring by grouping. So here I got 4. Well, as a matter of fact, here I only got here I actually only have 3 types of unlike term. These 2 terms can actually be combined. They are actually like terms. So technically, let me write this down and I will erase it. Okay. Technically, this polynomial is actually d squared plus 9d plus 14. So this particular example is actually not a factoring by grouping problem, because since these 2 terms can be combined, I'm actually have only 3 terms. So if you look at the exponent, this is actually 2, 1, 0 power. So this is actually a true trinomial. Okay, so this does not consider as a factoring by grouping problem. But just for a minute, let's pretend I have 4 unlike terms. So the first thing I do is group the first 2 terms and group the last 2 terms. Step number 2, factoring out the greatest common factor between the first 2 and the last 2. So between the first 2 terms, I can factor out a d. So what should I have left in my parentheses? Take 1d away from 2 of them, d to the first is left. Alright, plus take second term, take the only d to the outside, so positive 2 is left. Alright, between the last 2 terms, what I can factor out is a positive 7. So we have to write this positive 7 down. if you don't write the plus sign here, it will actually look like the whole answer is only one term. If I factor a positive 7 out, then that will be positive 7 times. 7 going to 7 one time, did not take out the d, so d to the first left. Positive 7 going to positive 14 is positive 2 times. Alright, so with this plus sign outside the parenthesis, it shows that right now I have two terms. And what's the same between the two terms is what's inside the parenthesis. So what do we call factors that are the same between the terms? We call them the greatest common factor. So now the greatest common factor between the two terms is actually d plus 2. And I will put them in the parenthesis because this is two terms representing one greatest common factor. So once we write the greatest common factor, we say times open parenthesis. Take the d plus 2 to the outside. Take the d plus 2 to the outside. The first term just left with a d. All right. Take this d plus 2 to the outside. The second term just left with positive 7. So my answer, d plus 2 times d plus 7. Okay. So basically, the idea of a factoring by grouping is start out with 4 terms. After factoring out the greatest common factor between the first two and the last two, then the next step, I should have 2 terms left. So factor again, then my final answer should only consist of 1 term. Okay? So this problem here to the right, again, is not a real factoring by grouping problem because these two are like terms. I can actually technically combine them. The reason why the homework has problem like this is actually trying to show us a different way to factor our trinomial. Okay, so when we get to module 13.2, I will show you a 5-step method on how to factor in trinomial. Alrighty, let's just pretend these two are not like terms. So let's factor the first two and the last two terms. Let's treat it like a difference. Let's treat it like a factoring by grouping problem. So between the first two terms, I can factor out a d. So what's left in the parenthesis, d going to d squared is d times, or you can say take 1d from 2, one of them is left. Alright, plus, take the only d to the outside, then positive 5 got no more variable left. Between the last two terms, since both of these last two terms are negative, I can factor out a negative 6. Then what's left? Negative 6 going to negative 6d, positive d times. Negative 6 going to negative 30, positive 5 times. So again, with the subtraction sign outside the parenthesis, that tells me now I got 2 terms. And what's the same between the 2 terms is what's inside the parenthesis. Okay? So we need to do whatever we got to do to make sure the 2 parentheses matched. Okay? Make sure what's inside the 2 parentheses are exactly the same 2 terms. Because in that case, the d plus 5 becomes my greatest common factor. So let's factor that out. Let's see what's left between the 2 terms. Take d plus 5 to the outside. D is the only thing left for the first term. So for the second term, take the d plus 5 to the outside. Then the only thing left for the second term got to be my negative 6. So that's my answer. All right. Now this is a real factoring by grouping problem because I do have 4 unlike terms. Okay, so let's take a look. I love a problem like this. So if we group the first 2 and the last 2, between the first 2 terms I can factor out an 8, and what's left is vx plus what? 5cq. So that means my second term, what's inside the parenthesis for my second term got to be exactly the same as what's inside the parenthesis for the first term. So between the last 2 terms, I actually cannot factor anything out between 64 and 5. Between qx and cv, I cannot factor anything out. So in that case, if I cannot factor anything out, that means the least I can factor out is a positive 1. But as you see, when I factor out a positive 1, these 2 terms remain to be exactly the same. in the parenthesis. Therefore, what's inside the parenthesis does not match at all. So, what do I do when the parenthesis does not match? We regroup. Rather than group the first two, last two, let's regroup them. Let's do first and the third, second and the fourth term. Let's see if that will work out for me. What that work out for me means see if it was inside the parentheses or the same. All right, between avx and positive 64qx, I can factor out an 8x, right? X repeated. All right, 8 going to a one time, take the only x to the outside, so v is the only thing left. 8 going to positive 64 is positive 8 times. Take the x to the outside, q is left. So v plus 8q is what's inside the parenthesis for the first term. All right, between the last two terms, I can factor out a positive 5c. All right, so positive 5 going to positive 40 is positive 8 times. Take the c to the outside, so q is left. Positive 5 going to positive 5 is positive 1 time. Take the c to the outside, v is the only thing left. So now I got two terms. All right, does what's inside the parenthesis match? Does what's inside the parenthesis match? Yes, it does, because inside the parenthesis I got two terms, a positive v and a positive 8q. So I got exactly the same two terms in both parentheses. Does the order matter? Does the order matters whether it's 8q plus v or v plus 8q? No, it does not matter according to commutative property. So my greatest common factor now is v plus 8q, or 8q plus v, however you want to write it. If I take this factor to the outside, then my first term only end up with ax. My second term only end up with positive 5c. So that's my answer. All right. Let's try this one right here. This is an interesting one. I'm going to put it right here. All right. Factoring by grouping. See four unlike terms. Group the first two and the last two. Between the first two terms, 6 and 15, I can factor out a 3. Between d squared and d to the third, I can factor out d squared. So let's see what's left. 3 going to 6 is 2 times. Take 2d from 3, d is left. 3 going to positive 15 is positive 5 times. Take both d to the outside, no d is left. Remember now, here I'm saying take both d to the outside, but reality is my greatest common factor, d squared, is going to that. It's actually going to that d squared only one time. Or you can say 3d squared, greatest common factor going to the second term, how many times? Exactly 5 times. 15 over 3 is 5. D squared cancels out. All right, I just don't write it out this way every time, but mathematically that's what's going on. All right, between the last two terms, there's actually no greatest common factor other than 1. Since both terms are negative, I can factor out a negative 1. Because if I factor out a negative 1 going to negative 2d is positive 2d. Negative 1 going to negative 5 is positive 5. So now I can actually get what's inside the parenthesis to match up. So now my greatest common factor is 2d plus 5. Let's factor that out. So what's left for my first term? 3d squared. What's left over for my second term? Negative 1. And that's my answer. All right. So in this lecture video, I demonstrate how to factor polynomials by the technique of factoring by grouping. Designed for polynomial that consists of 4 unlike terms with no greatest common factor between all 4 terms. Okay, that's what it's designed for. Despite that the first 2 example I did was not difference, is not a true difference square problem. And yeah, again, when you look at these answers, okay, when you look at these answers, you notice that when we finish writing our answers, all the answer consists of 1 term. Okay, that's what factoring does. Factoring allow us to take a polynomial consists of multiple terms and then break them down back to 1 term. Okay. All right, that will conclude this lecture video. Thank you for watching.